Today we are going to learn about production possibilities curve. In short, we call it PPC. So PPC is a graph that describes the maximum amount of one good that can be produced for every possible level of production of the other good. So let's understand this from an example. Suppose Chris is the only person in the economy and he can produce 6 units of shelter per week or 12 units of food per week. So here is the graph. On the horizontal axis, we have food production per week, and on the vertical axis, we have shelter production per week. So if Chris produces 0 units of shelter, what is the maximum amount of food that he can produce per week? That is 12, right? So here is 12. And let's increase the shelter production to 2 units. So what is the maximum amount of food that he can produce? So to produce 2 units of shelter, he's going to take 1/3 time, right? So what is the remaining time that he will have? So which is 2/3 time. And in this time, he will produce 8 units of food per week. So for 2 units of shelter production, we have 8 units of food per week. Similarly, if we increase the shelter production to 4 units, we'll get the maximum amount of food production is 4. 4 is the maximum amount of food that he can produce per week. And if he only produces shelter, then he can produce 6 units of shelter per week and 0 units of food. So when we connect these points, we'll get a straight line. And this is the PPC of Chris. So now what is the slope of this line? So the slope is basically given by the tangent, theta, tan theta. So what is the slope? So slope is -6 upon 12, which is -1 upon 2. And if we take the absolute value of the slope, then we'll get the positive 1 upon 2. Now let's calculate the opportunity cost of producing food. So what is the opportunity cost of producing food? That is 1/2, right? So here we can see that the slope of the PPC and the opportunity cost of producing food is exactly the same. And this is always true. Whatever is present on the horizontal axis, we find out the opportunity cost of that thing, it will always be equal to the slope of the PPC. So just keep this in mind. Now let's check these 4 points A, B, C, and D, whether these points are attainable and efficient. So attainable means basically whether we can produce these quantities or not, and efficient means whether there is wastage of some time. So since A, B, C, D points lie on PPC, so these quantities are attainable as well as efficient. There will be no wastage of time. Now let's check for the points E, which is below the line, and F, which is above the line. So now the point E is attainable because when we can produce 2 units of shelter and 4 units of food, right? But this is not on the line, this is below the line, so this is inefficient. There will be some wastage of time. And we can also uh, we can also see this through the calculation. So to produce 2 units of shelter, the time it will take he will take is 1/3, right? And the remaining time will be 2/3. Within this time he will produce 8 units of food, but in this case he is only producing 4 units of food. So certainly there will be some wastage of time. Now let's consider for the point F. So F lies outside the PPC, so this will not be attainable. That is unattainable point. Now let's consider another example. Let's say Dana is the single person in the economy, and she can produce 4 units of shelter per week or 4 units of food per week. So here is the graph. On the horizontal axis, we have food production per week. On the vertical axis, we have shelter production per week. And if Dana produces 0 units of shelter, then the maximum amount of food she can produce is 4 units. And similarly, the argument is basically same as we did in the previous example. So if we just do the same thing, we'll get the PPC of Dana. And let's find out the opportunity cost of producing food. So the opportunity cost of producing food for Dana is 1, right? This is just 4 divided by 4. And what is the slope of this PPC? So the slope is -4/4, which is -1. And if we take the absolute value of the slope, then we'll get 1. And this is equal to the opportunity cost of producing food. Now, let's understand the PPC in a 2-person economy. So, so far we saw the PPC of single person economy. So this was the PPC of Dana. This was Chris. So now we'll draw the PPC of a 2-person economy. So from the previous examples, we get the idea that in order to draw the PPC, we simply need to know the intercepts on both axes, and we connect those intercepts, we'll get the straight line, right? But is this also true for the 2-person economy? If we simply, let's say, the total amount of food production, if they work together, is 16, that is 4 plus 12, right? The 4 and 12 are the individual production, and if we just add them, we'll get the production if they work together, so that is 16. And for the shelter, if we add 6 and 4, we'll get 10 amount of shelter production. If we just connect these 2 points, we'll get a straight line. But is this the PPC? Is this the PPC for 2-person economy? So let's check this. So let's consider a midpoint of this straight line, which is 8,5, right? So now, since Chris has the lower, since Chris has the comparative advantage in producing uh, food, so Chris will produce food. So to produce 8 units of food is going to take 2/3 units of time, right? And the remaining time that he will have is 1/3. So within this time, he can produce 2 units of shelter. Is this correct? Okay, 2 units of shelter. And if Dana works full time on shelter, then she can produce 4 units of shelter. So if they work together, they can produce 8 units of food and 4 plus 2 units of shelter. All right, but this midpoint is 8,5. So certainly this midpoint does not lie on the PPC. of 2% economy, because what we are getting is 8,6, right? So 8,6 will be somewhere above this line. So this is wrong. This is not the PPC of 2% economy. Now let's understand what is the actual PPC of 2% economy. So let's go by definition. So the PPC describes that the maximum amount of one good that they can produce for every possible level of the production of the other good. So if both of them only produces food, then the total amount of food that they can produce is 16, right? That is 4 plus 12. And the total amount of shelter that they can produce is simply 6 plus 4, that is 10 units of shelter per week. Now let's increase the shelter production by a little bit. So since Dana has this is the PPC for Dana, and this is the PPC for Chris. Since Dana has the comparative advantage in the production of shelter, so we want Dana to produce the shelter. So if she produces the shelter by little amount, she has to sacrifice the food exactly by this length, right? Let me write the different color. Okay, exactly by this amount. So the total amount of food in the economy will decrease by exactly this amount, because Chris is still producing the food, and Dana is only sacrificing the food. So the total amount of food in the economy will decrease by exactly the length, of this line. So the point, will shift from here to here. Okay, this will shift here. Now let's connect these 2 points. So when we connect these 2 points, we'll get a straight line. Okay, and this line is parallel to the PPC of Dana, and it should be parallel because Dana is only making the switch. Chris is still producing the food, so this line should be parallel to the PPC of Dana. And similarly, we can increase the production of shelter by more, and we'll get a straight line which is parallel to the PPC of Dana. So after Dana reaches the 4 units of shelter production, she will run out of her time, right? She will have no time left for the production of shelter anymore. So now this is the time for Chris to produce the shelter. Okay, so now with the similar argument as before, the other half of the PPC will be parallel to the PPC of the Chris. Okay, so the first half is parallel to the PPC of Dana, and the second half of the PPC is parallel to the PPC of Chris. And when we and so basically the combination of these two PPCs is the PPC of 2% economy. So here we can see that the 2% economy, the PPC of 2% economy has these bulging things, this is bulging out. So the PPC of 2% economy will always be similar to this graph. This will always be bulging out. So the idea to draw the PPC comes from the low-hanging fruit principle. So this principle states that in expanding the production of any good, employ resources with lower opportunity cost. So this is what we did in while drawing the PPC of either 1% or 2% economy. So like we use we uh, we use Dana to produce shelter because he has the lower opportunity cost, producing shelter. And this is what this principle states. Like for Chris, the opportunity cost of an additional unit of food is half, and for Dana, the opportunity cost of additional unit of food is 1. Okay, so Chris has the lower opportunity cost for food. So if we want to produce little amount of food, then we want Chris to produce that amount because he has a lower opportunity cost in the production of food. But in this example, we increased shelter production by a little bit amount. So we want Dana to produce that, right? So this is exactly the low hanging fruit principle, and this principle can be used to draw 3% economy, PPC of 3% economy as well. Now let's do an example. So the question is, George and Tom are mechanics. Tom can replace 15 clutches per day or 10 sets of brakes. George can replace 10 clutches per day or 15 sets of brakes. Their garage provides full services, which includes replacing 1 clutch and 1 set of brakes. So how many more full services can they accomplish if they specialize? So this is a question of PPC of 2% economy. So now, before considering the specialization, let's consider if they do not specialize. First, let's find out the opportunity cost of replacing a set of brakes. So opportunity cost of replacing a set of brakes for Tom is 1.5 clutches, right? Okay, this is nothing but 15 over 10. And similarly, we can find out the opportunity cost of replacing a set of brakes for George is 2 over 3 clutches, right? Which is just the reciprocal of the previous one, which is 10 over 15. So now what is the equation of individual PPC? So let's draw the individual PPC. So this is the PPC of George. So this is the maximum amount of clutch that he can replace per day, and the horizontal axis gives the brake replacement that he can do per day, which is 15, and this will be 0. Okay, so what is the equation of this PPC? So here C represents clutch and B represents brake. So C equals to 10 is the y-intercept, so 10 minus. So the general equation of the equation of line is y equals to mx plus c, where m is the slope and c is the intercept. So 10 is the intercept, and minus shows that the line is downward sloping, and the intercept is basically 10 over 15, which is the opportunity cost of replacing a set of brakes. As I told you earlier, the slope and the opportunity cost of whatever on the horizontal axis is basically the same, right? So this is 2 over 3 b. Now since we are considering if George does not specialize, so what is the amount of full services that George can do if it does not specialize? So the full services means clutch replacement is equals to brake replacement, right? So now we have two equations, 1 and 2, so we can find out the C and B, right? Okay, so when we solve these two equations, we'll get C equals to 6, and B equals to 6. So 6, so the full service that he can do is 6 units. Now let's consider for the Tom, if it does not specialize. Let's draw the individual PPC for Tom. So again, on the horizontal axis we have brake replacement per day, and on the vertical axis we have clutch replacement per day. So here you can see that the steep of the line is, that is, I mean, the slope is higher in case of Tom compared to George. The steepness is higher in case of Tom than George, which is obvious because the opportunity cost, for Tom uh, of replacing a set of brakes is higher, right? For Tom, as you can see here, this is 1.5 and this is 2/3, which is less than 1. So for Tom, the opportunity cost is higher, and opportunity cost is basically the slope. So the slope will be higher, right? So the steepness will be higher for Tom. And the maximum amount that he can produce, that he can replace, is 10. And here for clutch replacement is 15. So the equation of this line is, again, C represents clutch and B represents brake. So y-intercept is 15 minus, because the line is downward sloping, and the slope is, or the opportunity cost is 1.5, which is 3/2 B. Now, for the full units of services, we need to equate clutch equals to brake, right? So here we have two equations. We can solve for C and B, and we'll get C equals to 6, B equals to 6. So if they do not specialize, the total unit of full services units of full services equals to 6 plus 6, right? If they do not specialize, that is, if they do the replacement individually, they can do the 12 units of full services. Now when they do it individually, when they do not specialize. Now let's consider when they specialize. So we need the PPC of 2% economy, and here I have drawn the PPC of 2% economy. So this is PPC of 2% economy. So I think you're clear about how to draw the PPC of 2% economy. We'll basically on the horizontal axis we'll add the individual replacement of brakes. So we have 10 plus 15, so we'll add and we get the 25 on the horizontal axis. Similarly, on the vertical axis we have 15 plus 10, which is again 25, and this point is called kink. So in order to find this point, we use the low-hanging fruit principle. That is, we first start from the lower opportunity cost. Okay, so now to draw the PPC of 2% economy, we need two half of the curve. So this is the second half, this is the first half, and the first half of the PPC will be parallel to the individual PPC of George, right? Because George will be the one to make the switch, since he has the lower opportunity cost in replacing the clutch, right? So George will sacrifice 15 units of break, okay, until he reaches at this point 10. So the x coordinate of this king will be 15, and after George reaches this point, Tom will be the one to do the cloth replacement. Okay, so until then, uh, Tom is producing 15 unit of cloth, right? So the y coordinate will be basically 15, and this is what we did in the previous graph. So if you're confused, you can refer back to the previous graph and then again come back to this question. You can watch the videos as many times as you can, right? Okay, so now we got the king and we have three intercepts, so we basically connect these points and we'll get the PPC of 2% economy. And now so this is the PPC. So now to obtain the full services that they can do together is basically we need to draw a line, you know, that is at the 45 degree from the horizontal axis, okay, and passes through the origin, because in order to do the full services of clutch and brakes, we need to equate C equals to B, right? So this is nothing but y equals to x, okay, and y equals to x. This equation always passes through the origin, and the angle formed by the line with the horizontal axis is always 45 degree, okay. So when we draw the line passing through the origin at 45 degree angle, the line will pass through this kink, okay, and the intersection of this line and the PPC gives us the units of full services that they can do together, which is 15 units, okay. So now let's compare this with the full services that they do when they do not specialize. So we had obtained 12 units of full services before. So what is the percentage increase in output? So that is 15 minus 12 divided by 12 times 100%, and this gives us 25% increase in output, which isn't bad. So this is the benefit of specialization, okay. So that's it for this video. So far we covered PPC of 1% economy and 2% economy, and in the next video we'll cover some other topics of microeconomics. So thanks so much for watching this video.